Alright, these are piecewise defined functions. First, it asks you to graph all the points that fit on the grid for both f and g. I always like to start with this x value for both, 5. If you plug 5 into that equation, calculate the y value, and go plot that point, that's the first thing I'm going to do. So 5 located up here would give us a 2. 2 squared is 4. 4 minus 1 is 3. So we chose 5, and we got 3 as our answer. Now the circle that you make, or the dot you make, is dependent upon your inequality. In this case, we make an open circle rather than a closed. This is to plot points for x values that are less than 5, so now we'll plug in 4. 4 plugged into that equation gives us 1, which is here. 3 plugged into the equation will give us 0, then a half, negative, etc. Continue graphing all the way off this graph, all points that fit on the grid. We should plug in 5 into this equation first. When you plug in 5 here, negative 1/2 times 5 is negative 2.5, plus the 4 is 1.5. I'll place that dot. It becomes a solid dot because our inequality has the equal sign below it. From here, I can use the rules of slope. The slope is negative 1/2, so I can go down 1, right 2, and graph all x values that are greater than 5 until it leaves the graph. So there is the original graph. The shifts in this particular graph are the left and right is located here. That's the opposite of that symbol, so this means left 2. The up or down shift is located here. In this case, the plus 6 means up 6. So all coordinate points that we've just graphed need to be moved. Left 2 and up 6. If I start with the open circle, left 2 and up 6, now located here. If I continue to move all of my coordinate points, left 2 and up 6, you have that sketch. Moving this guy left 2 and up 6 puts you here. Graph all points that fit on the grid. Don't put any arrows until you at least get to the edge of the graph. If you didn't want to put any arrows, that's fine by me. Now we need to write the equation that represents g of x. To do that, we take the left or right shift and we replace all the x's in the equation part here. If you were to write that out, which you don't need to, it would look like 2 to the x plus 2, which replaces that x. The minus 3 is still there. This minus 1 is still there, and the up or down shift, the new up or down shift, gets placed at the end of that, or here. Now a lot of this you can do in your head. You can combine like terms in your head and you don't need to show this. On the top we have 2 to the x minus 1, and if we combine like terms here, it ends with plus 5. Do the same thing for the bottom equation, sticking x plus 2 in for the x. We would have negative 1/2 times x plus 2, and sticking the plus 6 at the end of that plus 4. Because this is a line, I'm going to put the word simplify. That is so mx plus b is your final answer for lines. So if we distribute the negative 1/2, yikes. To get rid of the parentheses, and now combine like terms, I have negative 1/2 x plus 9. Don't forget to change the domain restriction. The domain restriction on the original graph was this 5, and now it's at 3. What affects that? The left or right shift. This has been moved left 2. The up or down shift doesn't change the domain restriction. Moving the cutoffs from 5's left 2 now puts the cutoff at the x value of 3. So both of these 5's need to become 3's. And there is your equation, and that concludes that problem. Okay, I'm going to throw up problem number 2. You'll need to copy it down. So you'll need a little bit of time. Go ahead and press pause, and I'll show the answer right now. Press pause. And here's the solution for problem number 2. One thing to remember, don't put any arrows here. This is a square root graph. You don't want to have imaginary numbers. We're not graphing imaginary numbers, so they come to a halt right there when the square root gets to 0. Okay, here's problem number 3. Copy that problem down. You'll need to press pause. Press pause now.
Oh, there's a kick.
And here's the solution to problem number 3. What you have to watch out for here, the original graph is this top graph. Because this is an absolute value graph, which is like the shape of a letter V, the V takes place outside the grid that I've provided. So when you move this graph back onto the grid, you cannot forget that the graph bounces up. Sometimes it's easier to figure out the equation by using your rules of plugging in x plus 5 for the x and the minus 4 at the end to write your equation, and then take a look at your new equation and figure out where the vertex is. The vertex on our equation here is right 6. 1, 2, 3, 4, 5, 6. There's no up or down shift because that 4 and that 4 canceled. So I don't have anything here, which means 6, 0 is the vertex. And it's at that point where it bounces back up. But we just can't see it from the original graph, done on purpose, so don't get fooled with that. That's Piecewise Graphs.